Paul McWhorter has a series of lessons on the Raspberry Pi Pico microcontroller. In this video, we will go through his homework assignment for lesson 33. I've taken the liberty of capturing a frame from Paul's lesson 33. In this screenshot, he shows the color wheel, and it's a circle going from 0 to back to 360 counterclockwise. And he's divided it up into 6 sectors. The first going from 0 to 60, and then from 60 to 120, 120 to 180, and so on, all the way back to 360, which brings us back to 0. To the right of that, he shows what we would need to do to an RGB LED to get the colors as we increment through this color wheel. He starts out at 0 degrees with the red fully on, the blue and the green turned completely off. And as we step through the sector, we gradually, in a linear fashion, increment the blue value for the RGB. And then once we get there, we now have the red and blue completely on and the green off. If you look at the color wheel, that should give us a magenta color. And then once we get there, we start decreasing the red, leave the blue on, leave the green off, and we come down to the value at 120. And if you look at 120, you should see a blue color because only the blue is on. Then likewise, we now have the red and green off and the blue completely on, and we gradually increase the green. And when we do that, we have the green and the blue completely on, the red off, and down here at 180, we have the cyan color. And then we go through the same procedure. We end up at angle 240, and at 240 we should see green because we have only the green on. And then to get to 300, we gradually increase the red, so when we get to 300 we have the red and the green on and the blue off. And if you look at that, we should see a yellow color. And then finally, we decrease the green back down to 0 and leave the red fully on, and we're back to full red. Now let's take a look at how the RGB LED is wired. If you look at the top rail, that's our ground, and we have the ground jumpered to the ground pin on the Pico. I also have a couple of red jumpers, and these are leftovers from a previous project that we're not really using in this assignment. And then we have the ground connected to the ground pin of the LED, which is second from the left in this case, the way I have the LED mounted on the solderless breadboard. Now if we take a look at the RGB pins, we see that the red is connected by way of a current limiting resistor to GPIO pin 15 of the Pico. Likewise, the green, which is third from the left, is jumpered through a current limiting resistor, and it goes to pin 14 of the Pico. And at last, on the far right, we have the blue pin, and the blue pin is connected with this through the current limiting resistor to pin 13, GPIO pin 13 of the Pico. Now let's go through the implementation of the homework assignment. Up here in the upper right, I have the breadboard, and I've covered the RGB LED with a ping pong ball to diffuse the light. It's very difficult to see the colors directly with the LED. Now let's start running this pre-recorded video, and then while that's running, take a look at the code. Line 1, from the machine library, we import PWM and pin. PWN stands for pulse width modulation. Paul has a lesson on pulse width modulation, and I'm not going to go into great detail about how that works. We also, from the time library, import sleep. That allows us to delay for a given amount of time. And what I've done is set my delay to 1/4 of a second. That means, and the way I use that is every time I set a color on the RGB, I leave it there for 1/4 second. Now, I have a max value of 65,535. That's the maximum number you can have in a 16-bit integer. For pulse width modulation, we can have a value anywhere from 0 to the max value. In the next 3 lines, we have the pin assignments. Red is at GPIO pin 15, green is GPIO pin 14, and blue is GPIO pin 13. And 12 through 14 sets those all set up to be as in the pulse width modulation mode. Now in pulse width modulation, we send out a large number of pulses to the pin, and in this case we're sending 1,000 per second. And that's done for the red, green, and blue. And then if we want to turn something on, we set up the duty cycle. The duty cycle says, well, how many of those pulses are going to have the LED on, and how many are going to be off? Well, the duty cycle is how many they're on, and I've initially set them all up to 0. Then there's a function where I output the values for the red, green, and blue LEDs by a line in the code as we step through. We output the red, green, and blue values passed to this function. Now let's start to see how we implement this. I first have a counter set to 0, and this counter I is used to tell me where I am in the color wheel. It'll go from 0 to 360. I've decided to increment the steps as in 1 degree. If we do something different, like a 1/2 degree or 1/10 of a degree or something of that sort, well, then it's going to involve more math, and I decided to make it easy. I'll just do 1 degree at a time. And again, I've output all zeros to the LEDs. I leave it there for 2 seconds, and let's start our loop. We first output to the RGB LED. The red is fully on, the green and blue are off. I delay for 1/4 of a second, and I start setting this up for a loop within the sector. Of course, the red is max again, the green is off, and J is the counter for within the loop, 1 degree per step. Okay, we go from 0 up to through 59, if it's less than 60. I calculate what value we're going to set up by dividing the J value by 60 and multiplying that by the max value and making that an integer value. And I output through the values to the output LED function. I have a print statement in the shell that show for me to see what's going on. The I is, as I said, is where we are in the color wheel. J is where we are in the sector, and then what the values of RGB are, and then I have it set up to overwrite it for the next time through. I sleep for 1/4 of a second. I increment the degree counter, the sector degree counter, and increment the color wheel counter. And then when that's all done, we will start working on the next sector from 0 to 120. As we said in the previous video, the green is going to be off at this point. The blue is going to be completely on. And then we set up a loop to start decrementing the red. And it's very similar to the line above, except when we come through this and we print the first output, after that we delay 1/4 of a second, and then in this case we're going to decrement the sector counter and increment the color wheel counter. And if we go through the other steps, you'll see that from 120 to 180, it's very similar to the first sector, except where we start, we're incrementing the sector counter. And if we go to 180 to 240, we're decrementing the sector counter. In the last two, again, from 240 to 300, we're incrementing the sector counter. And in the 300 to 360 sector, we're decrementing the degree counter. When we're at the end, we set the LEDs all off again, and we'll go back up and do this again. Now, for those of you that are more experienced, you notice that since we have a lot of code here that's very similar, when you have similar lines of code, that leads it the possibility of reducing the number of lines in the program by writing functions. We could possibly have a function that does the increase. We could have another function for decreasing, or we could even have one function that does both, and you merely pass on an argument as to which it's going to be doing. Now, if we go back up and look at the beginning again, let's go back up here and start the program. We start it, we'll see a little delay, and then we come down through here, and in the shell we will see the counters going as to what's going on. We're in the first sector here, and the color wheel and the sector counter are both the same, and you'll see the blue is increasing. Now when we go to the second, you'll see the red decreasing and the blue is maximum and the green is off. And we would get back to 120. Now you'll see the sector counter is incrementing. The red is off, the green is incrementing, and the blue is max. When you get to 180, then we start decrementing the blue, leave the green completely on, and the red completely off. And that does that until we get down to 240. When we get to 240, you'll see that the red is incrementing, the blue is completely on, or rather the green is completely on and the blue is off. And then when we get to 300, you'll see that the green is decrementing and the blue is off. And then we get back up to 360. We'll start this all over again.